Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll be considering a very interesting question right here. That is to evaluate integral of x e raised power minus x squared dx from -1 to 2. And if you have followed my basic calculus course, you will discover that this kind of expression is called a definite integral because it has limits. So it means that at the end of the day, you're going to get an expression that will be actually a number or something that can be evaluated to become a number. All right. So that is actually a definite integral. Now, the other challenge with this question is this. If you see x e raised power minus x squared dx, it might be looking to you like, I mean, at first you may be confused. What exactly are you going to do with this? It's looking like you can do integration by parts, you know, but then if you ask me, that's like thinking too far. One quick check you can do is if you differentiate x squared, right? You can easily get something x that will cancel out this x and no x will be left anywhere else. So in that case, that should instruct you that, okay, what you can do is to do algebraic substitution. So, I mean, don't think too far when you see this kind of question, because, I mean, you can embark on integration by parts and then you'll be on the journey for a very long time. Okay, so, I mean, you can easily do algebraic substitution and you'll be fine here. So let's go and deal with this. Since we have agreed that we are going to use algebraic substitution, see what we get. So to evaluate all this now, to evaluate this, see, to evaluate integral from -1 to 2 of x e raised power minus x squared dx. So you just say, let u be x squared. So if u is x squared, that means that du dx, if you differentiate u with respect to x, you get 2x, all right? And if you cross multiply, right, you get 2x dx equals du, all right? And then dx itself, and once you make this statement, right, it means everything that was x here before will have to change to something in terms of u. But of course, you don't have to worry about this because it's definitely going to cancel out. So, I mean, that's it, the hope you have. So you have 2x dx equals du. So you make dx the subject, and then you have du over 2x. And with du over 2x now, that means that when next you are coming back here, dx is going to become du over 2x. And thankfully, x is going to cancel this x. So we're already happy. But then since it has limits, you don't want to leave these limits like this, because as far as these limits are concerned, this is more like x1 and this is like x2. So you have to change them to u1 and u2 because going by the transformation you have made already. So don't you ever forget that. Okay, so let's do the transformation for -1 and 2, because once you make a transformation, u equals x squared, it has to affect every x that will not be every x that will still be left at the end of the day. So also at x equals -1, right? At x equals -1, since you already said that u is x squared, right? So at x equals -1, so it means that u equals x squared. That's -1 squared, which is 1. Then at x equals 2, u is equal to x squared, that is 2 squared, which is 4. So it means that the integral now is going to be from 1 to 4. The integral is going to be from 1 to 4. So let's do the transformation. So, the original thing we had was this integral from -1 to 2 of x e raised power minus x squared dx. Now we've said this is e, and then we need x squared is u already. So we say x e raised power minus u. Then dx is du over dx. Then we leave this x here because we know x is going to cross x out. And then this is over 2, right? That's 1 over 2, which comes outside here. And then, of course, you have your 1 to 4, which the transformation we did. So you have to make sure the transformation is total, including the limits. That's one mistake people can make. You can just leave it as -1 to 2. That would be very wrong. And then now you have e raised power minus u du. And this looks pretty easy. Now, if you go the integration by parts way, you'll be there for a long time. Okay, so here now we have half. So to integrate this, of course, if you integrate e raised power u, you keep getting e raised power u forever and ever. Amen. Right? But then this is e raised power minus u. So the first thing you do here is differentiate minus u. You get -1. In the case of integration, the minus divides the result you get. So you already know you are going to have e raised power minus u there at the end of the day. But this minus is going to affect something. So differentiate minus, you get -1. So if you integrate this with respect to u, you get e raised power minus u divided by the minus one you get when you differentiate minus u with respect to u, right? Because now we have changed it to integrating with respect to u. So, since this is minus one, so you can take the minus outside. So you don't have anything affecting. So this minus now goes outside. That's why you have minus half here. And then you are left with just e raised power minus u inside. And of course, e raised power minus u is the same thing as 1 over e raised power u. E raised power minus u is 1 over e raised power u. And that's what we have here. So we have minus 1 over 2 into 1 over e raised power u from 1 to 4. Okay, so the next thing is you can now substitute the upper limit and the lower limit. You take their difference. So here you have minus 1 over 2, minus 1 over 2. So put 4 for you. So you have 1 over e raised power 4 minus 1 over e raised power 1. E has a value, right? I hope you know e is 2.718 if you like, but I'm not going that route. You could put that and you actually get exact results, but I'm leaving it in terms of u. So all I'm just doing is I'm taking the LCM of e raised power 4 and e raised power u, which is e raised power 1, which is e raised power 4. E raised power 4 and e raised power 4 is 1. 1 times 1 is 1. Then e raised power 1 and e raised power 4 is e raised power 3 times 1, e raised power 3. So I choose to stop here. You could go further by substituting 2.718 into all those values, and then you get some results. So I just choose to stop in this place. So thank you very much for coming this long. If you have not subscribed, be sure to do that and click the notification bell so you can always get notified when I have a new video. Don't forget to share to people. I know this will be very helpful to so many people. Don't forget to comment. Don't forget to like. And of course, if you have a topic you'd like me to treat, please let me know. If you also have a question you'd like me to take, I'll also do that. Thanks so much for always coming by. See you in the next video.